I'm Bram Valkenborg from the Soil Service of Belgium, and I'm going to present to you how we used NextLand in our irrigation advice. So the Soil Service of Belgium is one of the first spin-offs from the KU Leuven University, and we exist since 1945, and we do independent research and give advice on agricultural, horticultural, and environmental topics. So we give advice on liming, on manure practice, crop suitability, and also irrigation, what I'm going to present to you today. Our irrigation advice started in 1986 when we started to do first research on how we can practice the irrigation. And then 2 years later, we gave our first advice. Since then, we grew in Flanders, in Wallonia, so the French-speaking part of Belgium, and in the Netherlands. And this year, we had almost 300 fields for which we gave irrigation advice. As some of you know, the region where we work is quite densely populated and is often prone to drought stress. So our goal is to increase the efficiency of our water use for irrigation and for our crops. We give the farmers advice on a weekly basis, mostly through mails, but also through phone calls where we are in direct contact with the farmers. We base our advice on a model which we calibrate through field measurements. So people actually go on the field, take samples, which are then analyzed in the lab. And then this data is used for the calibration of the model. So a lot of parameters go in this model. These are mainly environmental parameters, such as the soil parameters, whether it's a sandy soil or a more clay soil, crop parameters, weather conditions, and evapotranspiration. We also take into account the water table depth on the field and any irrigation that is applied by the farm itself. This gets us then an output of a daily soil moisture depth, a soil moisture at different depths. Then let me go over to an example on how we use NextLand data. We used the CropSAR F-APAR data set provided by Vito. And this we use to fine-tune our crop parameters, or the KC. This shows how the crop is being developed over time. And the parameter changes both in value and when it is, and the period. So we start with an initial development stage, which go then over to a middle stage and then to the harvest of the crop. As you can see, we use the F-APAR data, and on the graph below, the red lines show the previous KC values, the previous crop parameters that we used to in our model, which we then adapted in time and in value based on the F-APAR data that we received from NextLand. So you see that we have then a better agreement on how the crop developed on the field over time. So our model is not perfect always, and that's why we use the field measurements. So let me first introduce you how the model can be read. So the blue line is a soil moisture at 30 centimeters. And then the lighter blue line is the one at 60 centimeters. That's where the crop gets most of the water for the development. Then also precipitation is taken into account by the blue bars. And we take field measurements, as I said before, to calibrate our model. Then when the soil moisture goes below a certain amount, which is indicated by the red line, or the irrigation threshold, we advise the farmers to perform an irrigation schedule. As you can see, the field measurements are not always into accordance with the soil moisture data. That's why we use the NextLand data to fine-tune this more. So changing the crop parameters, we went from this calibration to, so you see here the difference between the field measurements and the data and the model. And then we went from this to this result. So you can see that the field measurements are much closer to the model data in the end. This we could verify through another service provided by NextLand, which is the Van der Sat Soil Moisture service. It's a daily service provided daily, which provides cloud-free data at 100-meter resolution at 5-centimeter sensing depth. So it's suitable for us to verify if the trends in the soil moisture data provided by Van der Sat are similar to the trends of our model. Then on the plots on the right, you can see that we plotted the soil moisture of Van der Sat on the x-axis to our modeled soil moisture. And you can see there is a high agreement between both products. And this for both our crop parameter that we use normally and our adapted crop parameter. So it's for us, it's a verification to see if the model still predicts the reality. So in general conclusion, how NextLand helped us. At first place, it helped us a lot, saving time and money on data preparation and processing. We didn't need to consider spending time on clipping to accent or to extract time series from different satellite data. It was all provided to us in a time series. Cloud corrections were already done, so that was easy for us. And also, we didn't receive any raw data. We got the data we asked for directly in a nice content. Also handy is that multiple services are provided in one platform. So we didn't need to consult different platforms. It was all there. We used the Cropsar F upper and the Van der Sat Soil Moisture, but we're thinking on also planning to use the NDVI in the future. Then automatization is one thing, because we provide weekly advice to the farmers. We need some sort of automatization, and the API that is provided by NextLand helped us to download data on an automatic basis. And at last, we also spent less time on going onto the fields and take measurements from there, because we have a lot of data provided by satellites. It was still necessary to go into the field, but we could do it less, which saved us time and also money in the end. If there are any questions, I'd like to answer them in the end to the Q&A. Thank you very much.